Good morning, team. Today is Tuesday, May 12th, 2020, and we have 12 days left of school. So I'm super excited to do some review with you guys over these last few days. Today, we're actually going to take a look at rotation and revolution. If you haven't completed your Hello Morning survey, please stop the video and go take care of that now. Thanks, team. Let's jump into our science and COVID-19 fact of the day. So I thought this was really interesting because yesterday we actually reviewed adaptations. And today I was able to find some science related to that. So this is an article that was published on May 6th. And researchers at the University of Saskatchewan have published this article, and they are learning about bats' immunity systems and how it may explain how they actually can carry coronaviruses without actually getting sick. So here's an image from the article, and this just is showing them working with one of these bats, but they're really interested in studying how these viruses are jumping from bat populations over into humans. So the researchers at the University of Saskatchewan have found that bats injected with the MERS coronavirus, so this is not the same one that's causing the pandemic now, but it is related. There are a series of coronaviruses, and the COVID-19 is the result of SARS-CoV-2, which is very related to this one, okay? But they can survive for months as a result of adaptations from the bat and the virus working together. So basically what has happened is that the bat's immune system has undergone a change to be able to work with the virus in its body without it getting sick. These researchers believe that wet markets, these are markets where wildlife are sold, and habitat loss may be stressors that disrupt that balance, and that causes the virus to multiply and then eventually spill over into other species. So now I want to know what your opinion is after learning this information. We recently learned about human impact on ecosystems. Knowing that the wet markets and habitat loss may be part of the reason that this coronavirus is spilling over into other organisms, how does the current coronavirus pandemic exemplify or show the impact of humans on the bat's ecosystem? And how can we learn from this? So right now I'm going to give you 1 minute. Go to this post in Google Classroom and answer that question. How does this show the impact of our human behavior on the bat's ecosystem, and what can we learn from this? Go. Great. Now let's jump into our lesson for today. So we are going to quickly review rotation and revolution. I know that it's been a little while, so we are going to revisit these topics, okay? Our objectives for today: you'll be able to differentiate. Remember, that's tell the difference between Earth's cyclical just means it's like a pattern that happens over and over, movements, which are rotation and revolution. You'll be able to explain how Earth's rotation results in the day-night cycle, and explain how Earth's tilt and revolution result in seasons. So we're going to watch this quick video to review. At the end of this video, there's a little experiment where a light is used to represent the sun. And while you're watching that, I want you to think back to the experiment that we did with the illuminated orbiter. Remember, we put it in the middle of the class, and then I turned it around, and we were able to look at all of Earth's positions and talk about which seasons that they resulted in. So let's take a look at this video.
seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night, every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days, and that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Okay, so let's look at a couple of main ideas. Main idea number 1. Earth's rotation, spinning on its axis, results in day and night. Each rotation takes 24 hours. Main idea number 2. Earth's tilt, 23.5 degrees. Remember, it's tilted on its axis. And revolution, which is its orbit around the sun, results in seasons. The tilt creates uneven distribution of sunlight in the northern and southern hemispheres, which results in the 4 seasons. So as we saw in our classroom and as we saw in the video, when the axis is tilted away from the sun, like as in this image right here, it is winter and it would actually be summer in the south. In this position in orbit, the axis is tilted toward the sun, which means that the northern hemisphere would now get more sunlight and the southern hemisphere would get less sunlight, so it would be summer in the north and winter in the south. Now let's solve a problem using our Ruby strategies. So Our Ruby strategies, remember, we're going to read the question, we're going to read it again. So the model below, remember, a model is a representation, shows Earth in several positions relative to the sun. In which position is it winter in North America? Okay, so now we're going to find out our key pieces of information. Oops, sorry, team. So we know that a model is a representation, and we know that this shows Earth in several positions relative to the sun. In which position is it winter in North America? So I'm just going to put a box right here because this is really important. Now, I know that in winter, winter, the axis is tilted away from the sun. And I know that in North America is in the northern hemisphere, which is above the equator. So, sorry, team. Let's look at our different positions. In position 1, here's the equator, here is North America. I'm looking at the way that the sunlight is reflecting on the Earth. And in this position, it doesn't look like the Earth is tilted toward the sun or away from the sun. So I'm thinking that this might be spring or fall. Let's go to another position and just check it out. So let's look at position number 2. Now here I can see that here's my axis right here. This axis is tilted toward the sun. What that means is that there's going to be uneven distribution of sunlight. So if I look at the equator here, more sunlight is going to be on the top in the northern hemisphere than towards the bottom. So I'm going to put a box here and I'm going to say that this is summer in the north and winter in the south. That means that over here, if I look at this image, here's my axis. Here it's tilted away from the sun. So here I can see the distribution of the sunlight. There's going to be a lot more sunlight in the bottom, in the southern hemisphere, than in the top. So position number 4, I know, is going to be winter in the north and summer in the south. Now, our question asks us which position is it winter in North America. So I know based on looking at the images that the answer is number 4. So let's look at our answer choices. F says position 1 because North America receives the most direct sun. In position 1, North America isn't receiving the most direct sun, so I know that this is not correct. G says position 2 because North America is tilted toward the sun. In position 2, North America is tilted toward the sun, but we're looking for winter. Remember, we're not looking for summer, so I know that this is not the correct answer choice. H says position 3 because North America is parallel to the sun. I know that that's not correct because remember, I'm looking for winter, so I'm going to look for it to be tilted away. And then J says position 4 because North America is tilted away from the sun. So I know that this is my correct answer. Now, you're going to solve some problems on your own. When I say go, you're going to go to the next section of this Google form. You're going to use the reference pictures to answer the practice questions related to rotation and revolution. There are 3-star questions for rotation, 3-star questions for revolution. When you're done, you're going to turn it in Google Classroom. Of course, if you have any questions, reach out to me via email, or you can text or give me a call. I miss you guys so much, and I hope you have a great day. Bye, team.